are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So in this video, what we are going to move forward is one of the last legs of normalization, where we talk about the fourth normal form. So the fourth normal form comes into picture when multi-valued dependency occurs in a relation or a table. Okay. So first we'll define what the rules are for fourth normal form, right? Then we'll understand again the very idea on which the normal form is based on. Okay. So now we are talking about 4NF, which is fourth normal form. Now the rule for fourth normal form is that it should satisfy two conditions. First, it should be in Boy's chord normal form, okay, and the table should not have multi-valued dependency. So in order for a table to be in fourth normal form, first of all, it should be in 3.5 normal form, okay, and then it should not have any multi-valued dependency. Okay, it should not have any multi-valued dependency. Let's now try to understand what first multi-valued dependency is, and then we will ensure that it does not really happen in our tables. Okay, so now a table is said to have multi-valued dependency if the following conditions are true. Okay, for a dependency from A to B, if for a single value of A, multiple value of B exist, then the table has multi-valued dependency. So if you have a relation from A to B, right, and if we say that for a single value of A, multiple value of B exist, right, then we can say that multi-valued dependency exists. Okay. Second is also a table should have at least 3 columns, okay, for it to have multi-valued dependency. Multi-valued dependency can only exist if at least 3 columns are there or 3 attributes are there in a table. Okay. And for any relation A to B to C, right, a table R which has 3 columns A, B, C, if there is actually a multi-valued dependency between A and B and then B and C, right, if there is a multi-valued dependency between A and B, then B and C should be independent of each other. Let's say between A to B, there is actually multi-valued dependency that exists, right? If this actually happens, right, then we have to make sure that B and C are independent of each other. Okay, that's what it really means. And if all the conditions are true, right, if all the above 3 conditions are true for any table, then it means that it is supposed to have multi-valued dependency. Remember, all the 3 conditions should be true, okay, not 1 or 2 or anything. All the 3 should be true in order to actually say that multi-valued dependency exists. Again, we'll try to understand this very concept by taking an example. Let's say here we have college enrollment table with the columns student ID, the course and the hobby. Okay, so every student can be a part of multiple courses. Okay, student 1 is a part of science also, student 1 is a part of maths also. Okay, and corresponding to that, their hobby includes cricket as well as hockey. Okay, now as you can see in the above table, right, that the student with the student ID 1 has opted for 2 courses, correct, science and maths. That is what we saw over here, right, and here she has 2 hobbies as well, cricket as well as hockey, right. Now can you think of what problems can this kind of a structure really lead to, right? The problem is that, well, the 2 records for the student 1, right, will actually give rise to 2 more records, right, as you can see over here. Because for one student, 2 hobbies exist, right? Hence, along with both the courses also, these 2 hobbies should be specified. How come that in front of science, we just have cricket, right? It should happen that if there is a hobby, for science, if it's a course, the corresponding hockey is cricket, right? Then one time, if he or she has a second hobby also, you should mention hockey as well, right? And then if they have opted for maths also, then you should write maths 2 times, correct? Why? Because there were 2 corresponding hobbies for that. So you have to make sure that you account for all the possibilities, right, as shown in the example over here. Okay, that means for 2 records for the student ID 1, right, it actually give rises to 2 more records, right, because for one student 2 hobbies exist, right, and hence we have 2 courses also. So it's like a total of 4 combinations. As you can see now in this table also, there is actually no relationship whatsoever between courses and hobbies. It's just that one student has 2 courses, one student has 2 hobbies as well. Courses and hobbies are not related to each other. Course is related to student, hobby is related to student. Courses and hobbies are not related to each other. They are independent of each other. So there is a multi-value dependency that actually leads to the unnecessary repetition of data and other anomalies. See, how are the 3 rules satisfied in this situation? Okay, we had the student ID, we have the courses, and we have the hobbies. Okay, now here the second condition is satisfied, correct, because here we should have at least 3 columns. Yes, there are at least 3 columns. Okay, the first condition is for the dependency A to B, right, if for a single value of A, multiple value of B exists, then it is supposed to have multi-value dependency. And it is true as well that for a single value of science, we have cricket also and we have hockey also. So if I keep from A to B, A is considered as the course and B is considered as the hobbies, we can see that for a single subject or a course, we have 2 hobbies, correct? So the first condition is also satisfied. Now the third condition says that if the relationship A is B and if there is a multi-value dependency between A to B, right, that means there is a multi-value dependency from courses to hobbies, right, then it says that B and C should be independent of each other, where C is basically the student ID, which is actually true, right? That means B and C are actually independent of each other. So in this case, what we can say is that all the rules are satisfied, right? Over here, right, there is no, as in the table above, there is no relationship between courses and hobbies, right? They are basically independent of each other. Okay, yeah. Here in this case, instead of this, we can say that courses and hobbies are actually independent of each other, right? Instead of this. So we can say that there is a multi-value dependency which leads to unnecessary repetition of data and other anomalies as well. Now to make sure how to satisfy, we have to kind of remove multi-value dependency. For that, we will apply the concept of decomposition. Okay, so what we'll do is we'll actually differentiate courses and hobbies into 2 different tables. Courses will be student ID for a course and hobbies will go for student ID and a hobby. Okay, so here we can say that by disintegrating it, we are satisfying the condition. Now this relation satisfies the 4th normal form. a table can have functional dependency along with multi-valued dependency. Now in this case, the functionally dependent columns, right, the dependent columns are moved into a separate table, and the multi-valued dependent columns are moved to a separate columns. Now if you actually design your databases carefully, you can avoid these issues. Okay, all right, let me just quickly reiterate on this very idea that when you have student and when you have hobbies, right, how are these two all associated? Okay, so let's go back to the very rules again and then we'll understand. Fourth normal form, for a rule or for a fourth normal form normalization to be true, first it should be in Boy's squad normal form and there should not be any multi-valued dependency. Okay, so you can see over here, how do we have multi-valued dependency? The first is that if A is dependent for a dependency from A to B, right, for a single attribute of value of A, multiple values of B should exist, right, which is true as well. A, B, C. A is student ID over here, it is not courses and hobbies. B is, let's say, courses, and C is, let's say, hobbies. Okay, and what is the data over here? Right, so here what you can see is for a dependency from A to B, right, for a single value of A, which is 1, multiple values of B exist, right, where A is the ID and B is the courses, correct? For a single value of student ID 1, there are multiple options existing. So the first condition is satisfied, right? If I have A to B, for a single value of A, multiple value of B exist. The second rule was that it should have at least greater than or equal to 3 columns. And it is true as well because this table also has 3 columns. Okay. And the third is, if there is a multi-value dependency from A to B, then B and C should be independent of each other, which is indeed true as well because there is no relation whatsoever between courses and hobbies. Okay, there is no relation between courses and hobbies, and hence they are independent of each other. And it says that for any relation from A to B and C, if there is a multi-value dependency that exists between A to B, then B and C should be independent of each other. Okay, and since all the 3 conditions are satisfied over here, we can say multi-value dependency exists. And how did we now solve this problem? We basically divided ID, course into a table, and then ID and hobbies into a table. Okay, that is how we basically solved the problem. To satisfy the fourth normal form, we decompose the tables into 2 tables. Okay, student ID and course, and student ID and hobby. Okay, and that is why what it says over here, that this satisfies the fourth normal form. A table can have functional dependency also, and a table can have multi-valued dependency also. In those cases, what do you really do? You take the functionally dependent columns and move them to a separate table, and the multi-valued dependent columns also are moved to a separate table. So this column also moved to a separate table, and this column also moved to a separate table in order to actually remove the multi-valued dependency. So you should take care that you design databases in such a way that you get rid of all of these dependencies. Okay. So with this, we actually conclude our discussion for all the normal forms and for all the normalizations that we have. Okay. So just to reiterate, we've basically introduced normalization so that the redundancy and the repetition in the code is kept to bare minimum. We first talked about the first normal form where every value should be atomic, right? There should be no multi-valued and composite, I would say, attributes allowed. Second was 2NF, right? For it to be in 2NF, first it should be in 1NF, and there should not be any partial dependency that was allowed, right? The third one is when we had in 3NF. In 3NF, there is no kind of transitive dependency is allowed, and it should be also always in 2NF first. And in the fourth one, we have 3.5NF, right? So in 3.5NF, it was Boy's squad normal forms that if this kind of a dependency happen, if this is a prime attribute, right, then this should also be a prime attribute, right? That means if B is prime attribute, then A should also be a prime attribute. Okay, and the last one that we talked about is fourth normal form. Okay, for the fourth normal form, there should not be any multi-valued dependency. So this is all what we kind of concluded when we talked about the concept of normalization and all the normal forms. And I hope this is clear to everyone and you understood all part of it. Normalization, to be honest, is a very, very, very important topic. It is very frequently asked as well, and it is very important that you understand it in great detail, right? When you are able to understand each and every normal form, it actually helps you to become clearer with the topic when you take examples on your own. One thing to another remember over here is when we talk about the concept of normalization, usually we go up till 3 normalization, okay? And if the data is very complex and is not designed well, then it becomes kind of difficult to move to the 4th and the 5th point. But if you have very well designing of data, it's usually easy and not very difficult to go to 5th normal form, but the 4th normal form. But the usual practical way of doing this is that we ideally go till 3rd normal form, and then usually it's more or less on a case to case basis if we want to go further or not. Okay, that's what the realistic idea is, but in theoretical manner we usually go to 4th normal form. There is 5th normal form also, but it's not a part of this course, so you don't have to worry about it. But yes, that also exists, that you should know. So with this, we are actually concluding with the topic of normalization. It's a vast topic. It requires a good knowledge of all the topics that we have done. Usually student gets confused a lot between partial, transitive, multi-valued, functional, right? There are a lot of terms, so it's quite easy to get confused since they all sound a little bit similar. So make sure you practice, right? Because the more you practice, the more you comfortable become with these topics. Usually for normalization, there's not like theoretical question asked. It's mostly about you're given a data and you have to take it to 3rd normal form. Okay, so you have to reduce it to different normal forms step by step. That is how usually this topic is really asked. Otherwise, it's mostly case to case basis as well. But normalization is one of the most important topics, right? So you have to make sure you put in that much effort as well to fully understand this. Okay, so thank you so much for attending this session. I hope I was helpful in able to make you understand this topic and make you more comfortable with the overall idea with how the concept of normalization works. Okay, so thank you so much for attending this, and I will definitely meet you in the next video. Bye.